Chuck,
Yes.
hey dude, now that 2022 is in the books,
A distant memory.
it's time to catch up on what kind of climate occurred in that year. And to do that, we're going to our man about town for climate. That's
Our man about the globe.
the global town,
Yeah.
Gavin Schmidt. Gavin, thanks for coming back to Star Talk.
Thanks for having me. Great to be here.
Yeah, so you are director of NASA's Goddard Institute for Space Studies, which is right here in Manhattan, in New York City. It doesn't have a huge storefront like Kennedy Space Center or NASA headquarters or JPL, but you guys are you're the branch of NASA that concerns itself with weather and climate, not only on Earth but on any planet that has it. Is that a fair overview?
Yeah, that's exactly right. I mean, we started off as the theoretical division, and we've moved very much into climate observations, understanding those, climate modeling, trying to work out why things are changing, and then what might be happening in the future. And now that has drifted off into exoplanet climate and climates of the
exoplanets.
planets. Yeah.
You just taken over the universe now.
Yeah.
I was happy to give you Earth in the solar system,
Right.
but no.
And I thought Starbucks was aggressive with their expansion. Damn.
So it turns out that the physics of the climate on TRAPPIST 1e is the same as the physics of the climate on Earth, and the same as the physics of climate of Venus 3 billion years ago. And so we can use the same understanding, the same tools, to explore all of them.
Wow.
So you're also a PI, principal investigator, on the Model E Earth system. Now, what is that?
So that's that's the framework that we use for doing the climate modeling. So it has modules for the ocean and the atmosphere and clouds and dust particles and all the interactions between them. And you can move it around, right? So you can move it around the universe. You can make the planet smaller. You can change the kind of sun that you're orbiting around. You can change the orbit. You can have it be tidally locked.
These are control knobs, basically, to test the causes and effects of changes.
That's right. And then you can change the amount of greenhouse gases. You can change the amount of air pollution. You can wobble the Earth's orbit, and then you can just see, what do you predict is going to come out of that? And
Okay, so Chuck, you know what's going on here?
Yeah. But
This is the start of a simulation of a whole other universe, and maybe our knobs are getting turned by Gavins that are aliens.
Right.
oh,
And this whole thing is one big test experiment
Exactly.
to give them data for what they need.
For what they need.
Right.
That's it. So Gavin, tell me about the 2022 and the climate. There were some major climate events around the world. But first, let's start out. How did it rank among the sort of the warmest years ever on record?
Yes, so it was one of those.
Okay.
It was again another top 10 year. The exact ranking was fifth or sixth, depending on a couple of very minor details that don't really matter. And so you're looking at the last 9 years are the warmest 9 years on record. This decade is by far the warmest decade on record.
Wait, on record since when?
So our instrumental records, right? So using weather stations and ocean ship measurements and buoys to go back, we can go back to about the mid 19th century. Before that, you have to use things like tree rings and ice cores and cave records and other stuff. But in the record that we have since the 19th century, these are by far the warmest years, and this is the warmest decade. We think, adding that data on, that this is likely to have been the warmest for actually many thousands of years, and conceivably many hundreds of thousands of years.
And how much can we implicate those facts in major climactic events, such as Pakistan a third of Pakistan was underwater last year?
Yeah.
I mean,
yeah.
And they're still recovering. What's
So
I know people are resistant to say this caused that, but we can speak statistically about it, correct?
Yeah, we can. So the warming that we've seen, right? So we've seen about 2 degrees Fahrenheit warming since the late 19th century. That is enough to be impacting the weather. It's enough to be impacting the frequency and intensity of heat waves. It's enough to impact the intensity of rainfall. And we've been seeing that Hurricane Ian, Pakistan, now in California. We are seeing that is enough to implicate the rise in sea level and the changes in Arctic sea ice. All of these things are linked to that global mean temperature change that we've seen. And that change is because of us.
Is the rise in sea level a combination of the water getting warmer as well as glacial ice melting back into the oceans?
That's pretty much it. Yeah. So the water is getting warmer. So we're putting heat into the ocean like nobody's business. I mean, if I told you the unit that they measure that is, it's in zetajoules. Right?
Zetajoules. Oh my gosh.
Zeta,
Yes.
Zeta,
Okay.
Zeta. I don't know. Maybe that's
We would say zeta.
Anyway.
Zetta. The metric
Yes.
prefix above petajoules, which
way,
is the
way above.
Oh, is it way above?
Way
Excuse me.
above.
Yeah.
Excuse
So
me.
it's 10 to the power 22 joules. Right.
All
That's
right.
that's the unit that we're measuring these changes in. So that's a very big number. So that's
Right.
causing the ocean to expand, right? That's raising sea level, and then the heat itself is melting mountain glaciers around the world. It's melting Greenland. It's melting Antarctica, and so all of that ice that was ice is now water, and that's raising the sea level as well. So.
All right. So
Now, does sea level rise actually contribute to temperature increase? Because some would say no, that it seems like it should cool it down if you're putting frozen water, a water that was recently frozen, into the ocean, that would cool things off.
Well, but we're putting in lots more heat, so it's just melting the ice. Right?
gotcha.
So, so that doesn't cause temperature rise, but it does impact the damages caused by storms. Right. So the sea level rises, the storm surges become more damaging. It's pretty. It's pretty straightforward.
So, Gavin, I think a healthy skeptic would say, "Oh, come on now. How is it that you get to blame heavy rains as well as drought on the same phenomenon?
Exactly.
How can you?
Very suspicious.
Yeah. What's
The key thing to remember, particularly about rainfall, is that it's not raining everywhere at the same time. Right. So as things get warmer, there's generally more water vapor in the atmosphere. You can hold a lot more water in the atmosphere. And so that when you have a frontal system, when you have a rainfall event, when you have an atmospheric river, you're delivering a lot more water vapor potentially. And so that comes out in the statistics of rainfall. So when it rains, you're seeing a shift towards the more intense rainfall amount. So we've
did
seen
you
that,
use the
right?
term atmospheric river?
I did, yeah.
What is that?
So it's really neat. If you look at satellite photographs or satellite imagery of water vapor, right? It isn't just like a blob, right? There's more water in the tropics, right? Because it's warmer, and less water vapor in the poles. But the pattern of water vapor is very interesting, and what you get is these. They're called atmospheric rivers. They're these bands of very
Moisture flows.
very moisture laden bits of air. They look like filaments that come out of the tropics. They kind of spiral around, they get caught up in the storm systems, and then when they intersect with the continents, you get what we've seen in California very recently. You get absolutely massive downpours. And you can trace these things for thousands of miles, and so they look like they're rivers in the atmosphere, right?
Wow.
So that's what it's all about.
And speaking of California, one of the people were just like, well, you can't have it both ways. You can't bitch and complain that we're in a drought forever. And then when we get all this water, now you're complaining that, there's too much water. But what they don't understand is that the global warming creates these conditions where the ground, because of drought, becomes cement-like, so that when you get the water doesn't seep into the ground the way it's supposed to, and that actually creates all this incredible damage.
So that's a great example. Another example is places where you've had wildfires. So where you've had wildfires along the mountain sides, that actually kind of makes the soil less cohesive, and so when it rains, you get much bigger landslides and mudslides.
Right,
Yeah,
exactly.
so we saw that in Montecito. A couple of years ago, they had some fires. There were some big rains, massive landslides. So we're seeing similar things happening there. These things are pretty complex, but yeah, no, they're adding to the damages and the impacts of the change.
And what about the CO2 emission? Was there some measure of that for the year?
Yeah, unfortunately, we had a bit of a slump, which was good, right, during the pandemic when people
no one was going anywhere, right? Transportation.
Well, exactly. So transportation
footprint.
was much less. We were making less stuff. There was a lot less emissions. I think about a 16% drop in 2020. It kind of picked up again in 2021, and then in 2022 we're back at record levels of emissions of carbon dioxide. Unfortunately.
All right.
So
okay, we're back, baby. We're back.
No.
All right.
That's not good.
No, it's
right.
not. It's ridiculous. It's crazy.
All right. So, is there some tipping point that we should watch out for?
There's lots of thresholds in the system. There isn't.
I mean,
one...
you've got the model. You've got the model.
Yeah, no,
So
but there
you
isn't
can
one.
tweak knobs and say, "Oh my gosh."
Well, we do that, and but we don't talk about those in public.
I was going to say, I feel like Gavin's hiding something from us. Something tells me he is not letting on some information that we.
It's the emergency button on his site that says "Kiss your ass goodbye."
Right, yeah.
We really try not to do that. So we're looking at all these things. We're looking at lots of places where there could be thresholds crossed. We're looking at changes in the permafrost in the Arctic regions. We're looking at changes in the Amazon. We're looking at changes in the ocean currents.
But do you have a knob that controls the melting of permafrost that then exposes decomposing vegetation that would then release methane to add to the CO2 greenhouse?
Yeah, so that's exactly the kind of thing that we're looking at. And so right now we're seeing a little bit of that, but not enough to really be concerning. The big changes in methane seem to be related both to oil and gas activities, drilling, pipelines.
Mm-hmm. All right, now you bummed us out for 10 minutes here. Is there anything hopeful we can offer our viewers and listeners? Silence.
Okay, so
Yeah. Yeah,
I don't mean to laugh. It's sad, but
or it's just, or is it like you've won a month vacation in Bora Bora? The bad news is you've got 2 weeks to live.
no, right.
no, it's not. It's not that bad. What we know from our understanding of what's been going on, the fingerprints of change, is that what we said before, the trends up until now have been up to us. But the good news is that the trends going forward from now, they're also up to us, right? So what we do collectively makes a difference. Like if we stopped emitting carbon dioxide tomorrow, which isn't going to happen, but if we did, then temperatures wouldn't keep on rising. We'd be pretty much flat. We'd just stay where we are right now.
And we keep okay.
And so the difference between that and what's actually going to happen is our choices. How we choose to power our society, how we choose to get around, how we choose to build our cities, our buildings, our infrastructure. Those choices are ours, and we have agency. We can make better decisions, and there's lots of people making decisions at all sorts of levels. Right? There's individual consumers and parents and citizens and voters and letter writers, and all of those people can influence the people who are making decisions that are going to impact those emissions going forward.
Thank you so much for. Gosh, it's so great to hear a scientist who is well versed and credible say exactly that, because what you did was frame this as a holistic problem with solutions that have to approach it that way, instead of saying things like, well, individual efforts don't really do anything to solve this problem. And I hate when I hear scientists speak like that, because I think what the public hears is, well, then forget it. Not F it, but yeah, different F it. Forget it. Forget it, because there's nothing I can do. But what you're saying is everybody should do everything. Let's do it all.
Right. We wear multiple hats, and I've seen some of yours, so yeah, I know that that's true. We have a hat as a consumer. We have a hat as an advocate, as somebody that causes trouble, or we have you're a voter, you're a customer. Yeah, you have many different roles, and the more that we can kind of activate those roles to help people make better decisions, the happier we're going to be, I think.
So, Gavin, I like the way you framed that, because another way to think about it is, let's say aliens came to Earth and decided to pump CO2 into our atmosphere to smoke us out. We would cry foul, and we would assemble all the military and all possible forces to defeat this enemy that's trying to warm our Earth. Mm-hmm. And whereas we're warming Earth, so my gosh, we actually have power to change this.
Yeah.
It's not being exacted upon us from outside.
The calls are coming from inside the house.
The horror. So, Gavin, thanks for updating us on this past year. And so, what you're saying is floods, droughts. This is all the new normal at the intensities that we've been seeing, and if we don't do something about it, it'll do something about it for us.
Maybe slightly differently. I mean, so we've always had floods and heat waves and things, but what's happening now is that the extra warmth that we put in the system is juicing those systems. So
there you go.
So the heat waves are being juiced, right? So they're stronger and more intense than they used to be. The rainfall is being juiced. It's more intense than it used to be. The droughts, even if we can't predict how droughts are really going to evolve for very long, those droughts are being made more intense because of the extra heating. It's drying out the soils more than they would have done otherwise.
And this 2-degree change, that's an average. But what is the difference in temperature equatorially versus the Arctic?
Yeah, so that's a great question. So the 2 degrees Fahrenheit is the overall globe, right? So what we see is that on land it's warming by about 3 degrees Fahrenheit, and on ocean about 0.8, something like that. And in the northern hemisphere, it's warming more than in the southern hemisphere because there's more land, and it's warming most of all at about 3.5 to 4 times the rate of the global warming in the Arctic. And so things there are really changing very, very quickly.
So the Arctic there's 4, 5, 6 degrees warmer in the Arctic. Is that what you're saying?
Yeah, in the last 30 to 40 years, yeah.
Right. Okay, so it's not just 2 degrees everywhere, just to be clear. Right.
Isn't that always the case? The place that you need it not to be the most is the place that is the worst.
Some glaciers are in a hurry.
Exactly.
All right, I think we got to call it quits there.
Damn.
So, Gavin, we'll get you on the horn a year from now, and you better give us some good news.
My fingers are crossed, but I think that next year I will give you exactly the same information.
No. All right, so then it's up to the rest of us. All right,
we'll see. Go.
Yeah, we'll do what we can at every level. Like you said, it's not just are you using gas versus electricity, but are you writing to members of Congress? Are you buying products that reflect this need?
Are you talking about this with your friends and family? Right. Are you talking about this at your school or at your faith group? Are you making it real?
Making it real, and then responding to it because it's real.
Right.
Yeah.
So, all right, Gavin.
Okay.
You get back to your modeling. Your modeling career. Is that what you call
it? My modeling career was cut short at an early age.
Okay. But I'm delighted to learn of this Model E Earth system. It'll give you some power of understanding, if not detailed prediction, certainly generalized sense of what the causes and effects are of our actions or inaction.
Exactly. That's exactly what they're for. Yep.
Fate of our civilization. All right. Gavin, always good to have you. Chuck, good to have you there too.
Always a pleasure.
This has been another Star Talk Explainer with climate scientist Gavin Schmidt. Neil deGrasse Tyson here, your personal astrophysicist. Keep looking up.